Hi there, this is the second part of the acceleration practice questions, part of the A-level physics. So basically what you should do is pause the video, have a go at these questions, and then when you're ready to go for the answers, just press play and I'll show you how to do it. Okay, let's move on. So in this question, there's quite a lot of kilometers per hour. So what I'm going to do first of all is just show you how to convert kilometers per hour into meters per second. So for example, with the first one, we've got 800 kilometers per hour in 6 seconds, and we need to find the average acceleration. So acceleration is change in velocity divided by change in time, which is obviously relatively straightforward, but we need to convert the kilometers per hour. So if we've got 800 kilometers per hour, okay, all we need to do is change that into meters and seconds. So 800 kilometers is 800,000, or times 10 to the power of 3, divided by the amount of seconds in 1 hour. So the amount of seconds in 1 hour is 60 seconds and 60 minutes. So 60 times 60 is indeed 3,600 seconds. So the speed in meters per second will be 222.2 meters per second. If you need a shortcut, by the way, to go from kilometers per hour, I'll just do this as a bonus. If you go from kilometers per hour to meters per second, you just need to divide by 3.6, because obviously you're timesing by 1,000 to get from kilometers to meters, and then you're dividing by 3,600. And timesing by 1,000 divided by 3,600 is divided by 3.6. So if you just want to learn this one, or hopefully that made you realize, or you just want a quick way of doing it, that's how you do it. Okay. All right, let's look at part 2 and 3. This part 2 is looking for the average deceleration. So deceleration, oops, so much use, let's get rid of that. So deceleration will be the change in velocity divided by the change in time. Now the change in velocity is from 800 down to 0, so that'd be minus 222.2 to 222.2 divided by the time taken for that change to occur, which in this instance is the 2 seconds. Okay, so that would give us minus 111.1 meters per second squared. Now obviously the negative in that just tells us that it's deceleration. Now we need to do the distance the car travels for the entire journey. So we've got two distances to calculate. We've got the part 1 and part 2. So for distance, let's write SUV out first of all, and then I'll show you which equation it is. So for the first one, for example, the distance travelled is obviously s. The initial speed for the first one is 0, and the final speed is the 222.2 meters per second. The acceleration is whatever it was initially, and then the time taken is the 6 seconds. So what we can do is use s equals a half u plus v times the time. So to get s, we simply need to do 0.5 times u plus v, which in this case is 0 plus 222.2 times 6. So if you calculate that, times all those numbers together, you'll get a displacement that's equal to 666.6 meters. And then we simply just need to do the same for the deceleration. So let's do that again. So the displacement s, the initial speed this time is the 222.2. The final speed it's going to stop, it's going to be 0. Acceleration is whatever the acceleration was, it's not important. And the time taken would be 2 seconds. So we need to do the same thing again. So s equals a half u plus v times t. So that'd be 0.5 multiplied by u plus v, which is simply times 222.2. And this time the time is 2 seconds. So that gives us a displacement of 222.2 meters. Obviously they cancel. So then to get the final answer, we need to do 222.2 plus 666.6 meters. So that gives a total displacement of 888.8 meters. So hopefully that one went okay. And then what we can do is look at number 5 to finish off. So I'm going to get rid of this, do number 5. So on this one, an airplane accelerates from a standstill to 200 kilometers per hour in 25 seconds. Calculate the average acceleration. So basically we just need to get the velocity from kilometers per hour into meters per second. So if you remember, that's 200. If you remember, it's just divided by 3.6. If not, it's 200 kilometers in 1 hour. So that'll be 200 times 10 to the power 3 divided by 3,600, which is obviously the same as dividing by 3.6. So 200 times 10 to the 3 divided by the 3,600 gives us 55.5 meters per second. Then what we need to do is get the average acceleration. So average acceleration is simply change in velocity divided by the change in time. So the change in velocity we just calculated to be 55.5 meters per second divided by the change in time, and that took 25 seconds. So that gives us an acceleration of 2.22 meters per second squared. And then we just need to calculate the distance travelled. So what we could do is the same as last time. We could just use S equals half U plus V times time. So the displacement S, what we're looking for, is equal to 0.5 times U plus V. So U plus V, initial speed is 0, final velocity 55.5 meters per second, multiplied by time taken, which is 25 seconds. So if you put that in your calculator, you should get 694 meters, rounded up. Alright, hopefully that went okay. Hope those questions were relatively straightforward, yet helpful. And thanks for watching, and I'll speak to you soon.